In this video, I'm going to show you techniques in calculating limits. If you watch the other video I have on limits, the first one I've done is on graphical. I don't remember what I call it, but where I describe the concept using graphs. Okay, this one is going to go much easier because we're not going to use any charts or graphs. Okay, I'm going to show you techniques. Okay, the first technique you should always do to do limits is actually substitute the x value is approaching into the function and see if you get an answer. Okay, so I'm actually approaching 3, so I'm going to substitute 3 into that x and 3 up into this x, where x squared is. We're going to see that we're going to have x 3 squared minus 9 over 3 minus 3, and we'll get a 9 minus 9, and we're going to get a 0 on the bottom. We're going to get a 0 over 0. Okay, when that happens, we can't just stop and say, well, we can't find that limit. We have to do, most of the time, do some algebra to it to simplify it so we actually do get an answer. And this one's very easy. The main algebraic technique we're going to use is canceling. Okay, factoring and canceling. So let's factor the numerator. The x squared minus 9 is a difference of squares. So it means we can factor it to x minus 3 and then x plus 3. Okay, and we still have an x minus 3 in the bottom. And when we do that, we notice that we can cancel out an x minus 3. So this limit is actually equal to the limit as x approaches 3 of just the function x plus 3. And then now we actually can substitute the 3 in there, and we get an answer of 6. So our limit is 6. Let's try another one. Okay, here's another one. If we take the time to substitute the negative 1 into x squared, the negative 1 squared is actually a positive 1. Positive 1 minus 1 is 0. We have a 0 in the numerator. And the negative 1 plus the 1 in the denominator make another 0. So we have to do some algebra to this. And just like the first problem, we can actually factor this. So I'm going to rewrite this same way. Okay, I'm going to factor the x squared minus 1 to x minus 1, x plus 1, and we have an x plus 1 denominator. So I'll cancel out the x plus 1s this time. And so if we keep going, I'll say the limit as x approaches negative 1. And I have the function x minus 1. And now when I substitute the negative 1 into this function, alright, I'm okay. Okay, I have a negative 1 minus 1. So my answer is, for that limit, a negative 2. Okay. Alright, now this limit will sometimes get students. It's actually a very simple limit because, first of all, when you substitute 0 and 0, we'll get a 0 over 0. Okay, so that's not what we can do. We can't substitute directly. So you notice that x squared is really an x times an x, and we have an x down there. So we can actually just cancel out a simple x from top and bottom. So we can rewrite this limit as this, and then we can substitute our 0 in, and our actual limit is 0. Okay? Alright, now maybe a little more difficult factoring, but again, we plug in 5, we get a 0 in the denominator. Now 0 in the denominator doesn't automatically mean, oh, we can't do this, we have to do something. Okay, if we have a non-zero in the numerator, we can say our limit is undefined. Okay, but if we substitute 5 in here also, 5 squared is a 25. That's 4 times 5 is a 20. We have minus 5. We do also still get it 0 over 0. Okay, so we see that 0 over 0. So let's try factoring it. So in the numerator, okay, I'm going to use x and x because x times x is that x squared, that first term. Our last term is a negative 5, so I can multiply a negative 1 times a 5 to get that, or a positive 1 times a negative 5. Well, I see that these two will actually add up to equal a negative 4, so this is how it factors: x plus 1, x minus 5. Okay, I have an x minus 5 in the denominator. Okay, and that, I mean, this really gives you a clue anyway how to factor the numerator most of the time. So, all right, we see the x minus 5's cancel, and so we have this is equal to the limit as x approaches 5 of x plus 1. Substitute our 5 in there. Our limit is a 6. Okay. Alright, let's try one more like that. Again, if we plug in negative 2, certainly get a 0 in the denominator. A negative 2 squared is a 4 in the numerator. 5 times a negative 2 is a negative 10. Alright, we get a 0 over 0 again. Okay, so let's try factoring x plus 2 in the denominator. Okay, in the numerator. Again, I always start out x and x. Our last term is a 6. I know 2 times 3 equals that 6. And 2 plus 3 equals that 5 there. Okay, so I know it's a plus 2 and a plus 3. X plus 2's cancel. So we have the limit as x approaches negative 2 of x plus 3. And we plug in negative 2. Negative 2 plus 3. Our final answer is, that limit is 1. So it's really emphasizing factoring skills. Okay, all right, let's try this one. Okay, now this is a different kind. Well, first of all, let's plug in 4. We can see right away we get a 0 in the denominator. That's the easy part. Okay, when we substitute 4 up here, we have to square it first. We get a 16. And that 2 in front multiplies that 16 times 2. We get a 32. And of course, we have another x up there. With that 4 has to substitute there also. 8 times 4 is also 32. So, yep, we get a 0 over 0. So we have to factor it now. Okay, now this type of factoring is common factoring, because if you look in the numerator, both terms have an x in there. Okay, so they have something in common. They also are both multiples of 2. Okay, the 2 of course is 2 times 1, and the 4, the 8 is a 2 times a 4. So they also have a 2 in common. So what I do is I write what they have in common. They have a 2 in common, and they have an x in common. There's one x right there in the back. Okay, in the second term, there's one x right there, and this means there's two x's right there. Okay, so they have a single x in common. Okay, so I put the 2 and the x in the front of just one parenthesis. Okay, so if I take well, just do it this way. If I put an x in front, that means I'm going to take that one away. And I put a 2 in front, I took that 2 away. What's the only thing I have left of that first term, that 2x squared? Just an x. That goes right there. Okay. All right, let's see. What do I have here? I have one x. That was taken away. It was put in front. And the 8 was a 2 times a 4. And I took the 2 away. Okay, so I have a 4 left. And I have a minus there, so I just match that, minus 4. Okay, there's my factoring. Hey there. Okay, we see that these cancel. Cancel out the x minus 4. So I'm going to rewrite my limit. Of 2x, and now I can substitute my 4 in. 2 2 times 4, my answer is 8. Okay, so really have to really work on the factoring skills. I've done other videos on factoring. Okay, might be worth looking at. All right, now sometimes this bogs down students because these have e to the x functions in them. Okay, so these are actually factoring problems, and first of all, let's check. Let's substitute 0. Okay, e to the 0, and of course anything to the 0 power is a 1. So e to the 0 is a 1. So I would get a 1 minus 1 denominator. That's a 0. And when I plug 0 up here behind the 2, 2 times 0 is still 0. So I have another e to the 0 minus 1, and that's another 1 minus 1. Okay, so I have a 0 over 0. But this is where students have a problem factoring this. Okay, what do we do with that e to the 2x? Well, our laws of exponents say this. If I'm multiplying two things, they have the same base, I just add the exponents. Okay, so e to the x times e to the x is really equal to e to the 2x. Okay, so going backwards, this e to the 2x is really e to the x times e to the x. So it doesn't maybe look obvious, but this is another difference of squares problem. Okay, it factors to this e to the x minus 1 to e to the x plus 1. Just like x squared minus 4 would factor to x minus 2 and x plus 2. Okay, this is how e to the 2x minus 1 would factor. Okay, I have the e to the x minus 1 the denominator. Okay, I see, well, let me get all this extra stuff off here. Okay, we see that this cancels. Okay, so we would have the limit as x approaches 0 of e to the x plus 1. Okay, we substitute the 0, we get e to the 0 plus 1. E to the 0 is 1 plus 1. We get a final answer of 2. Okay, so that's one that students sometimes have trouble with because we don't do e to the 2x, hardly ever. Okay, all right, I did one kind of like that over here on the right. Okay, we have another e to the 2x. Okay, that's e to the x times e to the x. Okay, so this has 3 terms, so it's not a difference of squares. Okay, how do we factor this one? Okay, let me pull this over. Okay, it really would factor like you would factor this. Just imagine e to the 2x is the same as x squared. It would really factor exactly like that. X squared plus 2x minus 3. You'd say x and x. The 3 is a 1 times a 3, a negative 1 times a 3, or a 1 times a negative 3. Okay, and you'd say, well, I'm going to pick the negative 1 and the positive 3. Okay, well, that's the same thing you're going to do here. Okay, with this e to the 2x. We're going to say e to the x, e to the x, because they multiply to make e to the 2x. We have a negative 3, so that's a prime number, so 3 and 1, okay, 3 and 1, okay, and this is negative, so one's negative, one's positive, so I can put it anywhere. Okay, oh, it does matter. Okay, which one do I want negative? I want the 1 to be negative, and you can kind of tell by that right there. It gives you a hint, really strong hint, which one's negative. Okay, plus, and of course, if you're not sure, you can always go back and FOIL this. E to the x times e to the x. That's e to the 2x. E to the x times the negative 1. That's a negative e to the x. And then that plus 3 times e to the x. That's a positive 3 e to the x. And that positive 3 times the negative 1. That's a negative 3. And then we combine those two. Alright, but we got it factored right. Okay, denominator is e to the x minus 1, And sometimes just drawing parentheses around that factor in the bottom helps you see it better. Those two cancel. So we're going to rewrite our limit as a limit of e to the x plus 3 as x approaches 0, which is e to the 0 plus 3, 1 plus 3, you get a 4. Okay? Alright, let's try ones with logarithms, because we don't do many logarithms. Okay? First of all, this is a log. You see it spelled O-L-A-G, logarithm. And we just see log, that's understood to be log base 10. Okay? So just to check real quick, when we plug in 10, we would have log base 10 of that 10. Okay? And what's that equal? And remember, this 10 right here is the base. This number right here would be what I would call the answer. And this right here, whoops, that's the base. This is the exponent. I got it backwards. Okay? Okay. This would be the answer right there. This would be the exponent. So when you convert, you could change this logarithm form to this. The base, that's that 10. Okay? So you'd ask, well, okay, that 10 to what exponent? Okay, that exponent's that blank right there, equals, the answer is this 10 right here. I'll make that, well, I already got it blue, I'll make it orange. Okay, well, what exponent would make that work? That'd be 1. Okay, so long story short, okay, long story short, log of 10, that's a 1. Okay, then we have a subtract 1, so again, we get a 0 in the denominator. Okay? Alright, 0 in the denominator. Alright, what about when you substitute 10 up here? Okay, well, this is in case you're not understanding what this notation means. That means log, that's squaring the log. Okay, that means 2 of these. Okay, and just this is not a limit idea, but that's different from this right here. This means, alright, take the x and square them and then find the log of that. That's what that equals. Okay, so anyway, alright, so we're going to find log of 10 and we're going to square it, which is log of 10 is, the log log is 1. Okay, so 1 squared, we get 1 squared in the numerator minus 1. So again, all that to show you it's going to be 0 over 0. So now this can be factored. Okay, this numerator is really a difference of squared. It's like x squared minus 1, which we factor as x minus 1, x plus 1. So we'd factor this as log of x minus 1 times log of x plus 1. And we have a log of x minus 1 denominator. We see that they'll cancel out. So we rewrite our log as a limit as x approaches 10 of log of x plus 1. Okay, we substitute 10, we get log of 10 plus 1, and the calculator will tell you we get a 1 plus 1, which is 2. Okay, now your calculator probably has 2 logarithms on it. It has this right here and has this right here. Okay, this logarithm right here is logarithm with a base of 10. This ln down here is a logarithm with a base of e. Very different, so make sure if you're going to calculate this, use the correct calculator button. Alright, let's try the one on the right. Okay, alright, some students would stop at this, but, okay, log 10. Okay, log of 10 is 1. 1 minus 1 is 0. Alright, log of 10 squared is 1. Alright, 5 times log of 10 is a minus 5. And then plus 4 All right, we're going to get 0 over 0. So this is really all about factoring, and even unfamiliar functions that we don't practice factoring a lot. We probably need to practice more of that. Okay, so let's factor the numerator. Log of x in the first parenthesis, log of x in the second. Okay, our last numbers are 4. Now, what do I multiply to make a 4? We probably automatically think about 2 times 2. And of course, a negative 2 times negative 2 would also work. But these two add up to 4 and negative 4. We don't have either one in the middle. We have a negative 5. So 1 times 4, negative 1 times negative 4. Okay, also multiply to make that 4. Let's use a negative 1 and a negative 4. Okay, that's how we factor that. All right, we have a log of x minus 1 in the denominator. Okay, so we're going to factor out, cancel out the log x minus 1. We're going to rewrite. Log as x approaches 10 of log of x minus 4. All right, we substitute our 10. We get log of 10 minus 4. Log of 10 is a 1. Minus 4, we get a negative 3. All right. Since we mentioned, let's do the same thing. Let's do some natural logs. These are called natural logs. And of course, this time we're approaching not a whole number or integer. We're approaching the irrational number e. So, what's natural log of e? Natural log of e. Oh, well, natural log really stands for log base e of e. Okay, let's change some colors here. Okay, this red e is the base, and this e up here is really the answer. Okay, and this number that we don't know over here, we'll make that brown. Okay, that's the exponent. So I don't know, I'm really finding an exponent. Okay, so this base is red e to some power, supposed to equal this green e. Well, exponent 1. Okay, the answer is 1. Okay, so natural log of x, when I plug in e, is 1. 1 minus 1, that's 0. Okay, so we got 0 in the denominator. That's not good. Okay, so just like before with the common log, you know, log base 10 is called common log. That's a common log because we, I guess because we've been using base 10 for decimal system, but that's called the common log. Okay, natural log, that's called the ln, that's called a natural log. And just because the bases are different, this one has a base of 10, which is understood, and this one has a base of e. So it's one of those things where it's understood. Okay, so anyway, natural log of x squared. Okay, it means natural log times another natural log. All right, when we plug in e, we get 1 and a 1. Okay, so this right here just becomes a 1, and we subtract 1, we get 0. All right, no big surprise there. This is all about factoring, so let's factor. Okay, all right, so natural log of x squared, natural log of x squared, it's natural log of x, natural log of x, we got a 1 right there. Only thing we multiply by 1 is 1 and 1. It's a minus, 1's a positive, 1's a negative. Okay? Alright, we have a natural log of x minus 1 denominator. These cancel. Okay, rewrites. That becomes a limit as x approaches e. Natural log of x. Oops, I canceled out the wrong one up here. Okay, the minus 1's canceled. Okay. Up here. Okay, the minus 1's canceled. Okay, so natural log of x plus 1. Okay, Alright, substitute our e. Alright, natural log of e plus 1 is 1 plus 1. We get 2. Alright, over here on the right, we did another natural log. I did another natural log and another type of factoring. Okay. Now they put that back up there. Natural log of 1. Okay, so look carefully. This says natural log of x times another natural log of x. Let me rewrite that. This means a natural log of x times another natural log of x. And this means a natural log of x. And I'm going to sneak a little 1 there. Okay? And you'll see why. Alright, what do they have in common? They both have one natural log of x in common. Okay? So I'll put a natural log of x on the outside of one parenthesis this time. What did I not cancel out? On the first term, there's still a natural log of x, and that's why I put that 1 there. If I didn't have that 1 there, I wouldn't have anything to put there. I had to have something put there. Okay, so that's how that would factor. And you could just go ahead and distribute what I have factored there, and you wind up with the same thing. Alright, in the denominator I have a natural log of x minus 1. And you put parentheses around it so it kind of looks the same. Cancel these out. So we're going to rewrite that as a limit as x approaches e of natural log of x, which is going to be substitute e, natural log of e, which is 1. Okay. And I'm going to stop video here because I have a different technique to show you next.